Dear participants of the conference, to your attention are the results of the paper Multiparametric Profiling of a Linguistic Construction, Linguoquantitative and Machine Learning Aspects, presented by Solomija, Viktoriia Zhukovska, and Oleksandr. The presented paper aims to discuss the results of the Linguoquantitative multiparametric profiling of linguistic constructions, specifically focusing on English detached, nonfinite, and nonverbal with explicit subject constructions and adopting cognitive-quantitative construction grammar as a theoretical and methodological foundation. By integrating quantitative corpus linguistics and machine learning approaches, this study advances understanding of the determining properties that define the linguistic behavior of the analyzed constructions in present-day English. English detached, nonfinite, and nonverbal with explicit subject constructions such as her eyes growing perceptibly wider, hands in pockets, despite oil being the lifeblood of industrial society, what with her mother being immaculate too, as complex, close-level constructions possess several idiosyncratic properties that set them apart from other complex syntactic units. Different aspects of these syntactic patterns have been studied from the standpoint of various linguistic approaches and frameworks. Although many studies have been undertaken, the linguistic versatility of the analyzed patterns raises a number of questions that have not yet been finally resolved. Specifically, a comprehensive parametrization of their linguistic profiles to identify the determining properties that influence their linguistic behavior in present-day English has yet to be performed. Theoretical and methodological background of the presented research is defined by cognitive-quantitative construction grammar, that is, a novel research framework in cognitive grammar studies. This framework triangulates the theoretical and methodological underpinnings of cognitive semiotic grammar approaches with analytical and research tools of quantitative corpus linguistics to investigate general and idiosyncratic properties of linguistic constructions. Cognitive-quantitative construction grammar revitalizes the traditional concept of a construction, promoting it to the status of the basic unit for language representation and analysis. Constructions are conceptualized as emergent, cognitively entrenched symbolic units, conventionally used in a language society. They are considered to be pairings of generalized form and meaning or function. In this grammar theory, language consists of constructions, and constructions embrace all language levels, from morphemes and abstract clausal patterns to text types and genres, ultimately forming an organized inventory of constructional networks, that is, constructicon, constantly updated and adjusted by language usage. An in-depth examination of the linguistic properties of a particular linguistic construction can be performed by analyzing its essential form and meaning properties. The most effective analytical and research tool for examining the essential properties of a construction is a comprehensive methodology for multiparametric constructional profiling. In quantitative corpus studies, profiling refers to the process of establishing specific linguistic properties at a particular language level based on quantitative indicators of this property or parameter realization in the corpus, whereas the profile of a linguistic unit is a set of established quantitative indicators. The set of these properties determines the linguistic behavior of a construction. Multiparametric profiling is based on the procedure of a linguoquantitative parametrization. The procedure entails identifying and statistically verifying a set of essential linguistic properties, namely parameters, factors, and factor values of a linguistic construction that constitute its linguistic profile. Then linguistic parameters of a construction are realized in linguistic features of a particular language level, namely factors, which are then manifested in specific language categories, factor values. Nonfinite and nonverbal syntactic patterns with an explicit subject are considered syntagmatically and semantically complex, clause-level constructions in cognitive-quantitative construction grammar. The argument predicate structure of the analyzed constructions minimally consists of a predicate expressed by a nonfinite or nonverbal phrase and a subject expressed by a nominal or pronominal phrase. The close-level constructions are partially schematic, represented by obligatory lexically unspecified slots, subject and predicate, with an open slot for an augmenter, augmented or non-augmented constructions. These augmenters in present-day English are typically expressed by a limited number of units, namely with, without, despite, and what with. Multiparametric profiling of the detached constructions entails their linguoquantitative parametrization. So the research sample of the detached nonfinite and nonverbal with explicit subject constructions is obtained from the British National Corpus and includes 11,000 corpus contexts that instantiate 5 types of the analyzed constructions. The linguistic profiles of these constructions are parametrized through the quantitative verification of 7 parameters of their form, namely morphosyntactic, relational, referential, syntactic functional, positional, distributional, and punctuational, manifested in 12 factors and 34 factor values. Multiparametric profiling of the analyzed constructions entails a linguoquantitative parametrization through a corpus-based quantitative analysis that entails a 3-stage linguistic and quantitative procedure that consists of 3 statistical methods. Method of multivariate analysis of variance, 1-factor analysis of variance, and Yuki's multiple comparison method. This procedure is followed by verification of the obtained data through a machine learning experiment. The quantitative processing of empirical data is done with the statistical data analysis system, ART. So the computerized linguoquantitative parametrization presupposes the application of 3 statistical methods. Firstly, the quantitative data of the operationalized formal parameters are tested using multivariate analysis of variance, MANOVA. The obtained results demonstrate that the quantitative differences between the analyzed constructions are not present in 3 out of 12 factors. Next, the differences in the quantitative realizations of the factor values of the specified vectors are established. The 1-vector analysis of variance is used to determine statistically significant differences in the realization of a particular factor value. The analysis didn't reveal statistically significant differences in the realization of 3 factor values out of the 32 established factor values. The one-way method analysis of variance indicates the existence of differences but doesn't explain where these differences are most prominent. To solve this issue, the post hoc Tukey test is employed. The Tukey's multiple comparison method detects the constructions that exhibit statistically significant differences in the realization of specific factor values. The Tukey's test is quantified by comparing the indicators for a specific factor value in pairs of constructions. According to the number of statistically significant differences in the realization of the specified factor or factor value, we distinguish constructional linguistic profiles with high, medium, and low linguistic homogeneity. The statistical analysis of linguistic profiles of the detached nonfinite and nonverbal with explicit subject constructions demonstrates that some factors and factor values significantly influence their behavior in the corpus. To validate the obtained results, a machine learning experiment is conducted to establish the factors with the most significant capacity to differentiate between the types of the analyzed constructions beyond the corpus, that is, in present-day English. The use of machine learning technologies alongside traditional statistical approaches in language study is becoming more prevalent. In our study, we utilize linear discriminant analysis to determine the factors with the greatest potential for separation between the types of the analyzed constructions outside the British national corpus. The specialized package mass is used to build the model for linear discriminant analysis, and graphs are produced with ggplot2 library for our programming language. The results show a distinct separation of with-augmented and non-augmented constructions from other constructions submitted to the linear analysis. However, in the factor syntactic function to matrix clause, the despite augmented construction is also distinguished. The analysis of the confusion matrices reveals that for with and non-augmented constructions, the recall and precision values are pretty high, particularly for models with an overall accuracy of 0.7 and higher. It suggests a higher probability of their correct extraction by the created machine learning models. The specified factors may be ranked based on the model's accuracy. The results of the conducted machine learning experiment are very similar to those obtained by the Linguoquantitative parametrization of the constructional profiles. However, the overall efficiency of the constructed machine learning models to solve the problem of distinguishing the types of the detached nonfinite and nonverbal with explicit subject constructions beyond the corpus is not sufficient. The model effectively distinguishes the non-augmented and with augmented constructions, despite insufficient overall accuracy. However, despite what with and without augmented constructions are more challenging to classify. Provided an effective model is constructed, the specified factors of the analyzed linguistic parameters can be used to distinguish types of the detached nonfinite and nonverbal with explicit subject constructions in the present-day English usage. So, to sum up our presentation, it should be mentioned that the results of this study indicate a need for further research on the discussed issues. In future studies, it will be interesting to generate other types of machine learning models and assess their effectiveness in distinguishing between the types of the English detached nonfinite and nonverbal with explicit subject constructions based on the data sets for the parameters, factors, and factor values extracted from the corpus. So, thank you for your attention.